But it's not just in the temperature averages. We're seeing considerable impacts on our temperature extremes. And the next animation that you'll see is looking at how the temperature extremes, both the cold temperature extremes and the warm temperature extremes, have been changing over time. And we affectionately call this animation sort of the jelly on the plate animation, because what you're looking at there is the distribution of temperature anomalies. So you'll see that there's a lot of temperatures that are sort of clustered in around the middle, which is sort of where the average actually sits. But then on the right-hand side, you'll have the warm temperature anomalies, and on the left-hand side, you have the cold temperature anomalies. So as the animation starts, what you'll see is that the shape of that distribution of average and the extremes either side starts to change. And that by the time we get to the most recent period in the record, you'll see that compared to the very early distributions, which were sort of equal number of warm and cold extremes, the most recent distributions, you'll see that there's a very long tail of warm temperatures and extremely warm temperatures, and a slightly shorter series of cold extremes. And so that is how climate change is actually interacting with our extreme events too. So the frequency of heat waves and extreme heat is increasing dramatically across the entire planet. But the frequency of cold extremes is actually declining on average across the planet because of climate change. So that should give you some idea of both the natural variability, the time frames over which natural variability occur, which can be seasons within years and across decades, and how climate change is interacting with those.